Every email you send lives somewhere, every Netflix show, every AI argument at 2 a.m. But almost nobody knows where or how much it costs to own that somewhere. Everything related to the online world lives in a data center, and right now, in 2026, data centers are the single most in-demand piece of real estate on Earth. They are more valuable than skyscrapers, more strategically important than oil refineries, and almost nobody outside the tech industry knows how they actually work or how much they cost. Today, we're going to fix that. Welcome to the economics of owning a data center, the gold of this era. Let's make sure we're talking about the same thing. A data center is not a room with a cluster of computers placed in a compact area. It is a highly engineered, climate-controlled, bomb-proof warehouse filled with thousands of servers, connected by kilometers of fiber optic cable, consuming as much electricity as a small city, running 24 hours a day, 365 days a year, with zero tolerance for failure. When your bank processes a transaction, that happens in a data center. When you ask an AI a question, that happens in a data center. When a government stores its citizen records, they go to the data center. These buildings are not optional infrastructure, but they are the backbone of modern civilization. And right now, the world cannot build them fast enough. According to JLL's 2026 Global Data Center Outlook, the global data center sector is expected to nearly double from 103 gigawatts to 200 gigawatts of capacity by 2030. That's a $3 trillion investment supercycle. And you want a piece of it. So let's talk about what it actually takes to own a data center. There are different sizes of data centers, and the price range is enormous. At the small end, you have what's called an edge data center, a compact facility serving a local area. These can cost anywhere from $1 million to $10 million to build. Then you have mid-size enterprise data center, the kind of large company that might build for its own operations. They are used by those companies that have less use of AI, but they want it in their name so that they can make money out of it. Think $50 million to $200 million. Then you have hyperscale data centers, the giants in their field. The ones Google, Amazon, Meta, and Microsoft are building right now. A single 100 megawatt hyperscale facility typically costs between $900 million and $1.5 billion to construct. And ironically enough, AI is making everything more expensive. Standard data centers cost around $10 to $12 million per megawatt to build. But AI-ready facilities with the specialized power density needed to run GPU clusters can exceed $20 million per megawatt. In 2026, the average global construction cost per megawatt hit $11.3 million, up 6% from the year before, and rising at roughly 7% per year since 2020. If you want a respectable, mid-sized 30-megawatt facility, you're looking at somewhere between $300 million and $600 million, just to build it, not to run it, not to fill it with equipment, not to connect it to the internet, just to build the box and nothing else. Here is where your data center dream gets complicated and, frankly, annoying. Data centers run on electricity, and they do not use a small amount of it. A 100 megawatt facility running continuously consumes roughly 876 million kilowatt hours per year. To put that in perspective, you can power around 80,000 average American homes, or watch Netflix on a standard 4K smart TV continuously for 5.8 billion hours. But how much will it cost you? Not much, just $41 million and $131 million per year, depending on where you are building your data center. Electricity is so critical that your entire business strategy starts with one question: where can I get cheap, reliable power? This is why you see massive data centers built in cold, sparsely populated places like Iceland, Norway, and rural Virginia. Cold climate means free cooling. Low population means cheap land. And critically, you're not competing with millions of households for electricity. But here's the problem nobody warned you about. Getting connected to the grid takes up to 4 years. Right now, in 2026, the US electrical grid interconnection queue is so backlogged that the median time between applying for a grid connection and actually getting one has stretched to 54 months. That's 4.5 years of waiting. You can build your data center in 2 years. Then you wait another 4 just to plug it in. This is why tech companies like Microsoft and Amazon are now funding their own power generation, building natural gas turbines, signing nuclear energy deals, and buying entire solar farms just to bypass the queue. And if you can't do that, you wait just like the normal folks out there. Servers generate enormous amounts of heat. If you don't remove that heat, your servers melt, and you do not want that to happen. Cooling systems typically consume 30 to 55% of a data center's total energy usage. The industry measures efficiency using something called PUE, which stands for Power Usage Effectiveness. A perfect PUE of 1.0 means every watt of electricity goes directly to powering servers. A PUE of 2.0 means that for every watt of computing, you burn another watt just on cooling and overhead. The global average PUE is around 1.5. The best hyperscale facilities get below 1.2. Modern AI data centers are now moving to liquid cooling, essentially circulating cold water directly through server racks, because air conditioning simply can't handle the heat density of modern GPU clusters. Your cooling infrastructure alone can run to tens of millions of dollars to install, and millions more each year to operate. This is the part of the data center business nobody puts in the investor deck. Community opposition. Between March and June 2025 alone, local community opposition led to $98 billion worth of data center projects being blocked or delayed across the United States. At least 25 projects were canceled in 2025 in direct response to local objections. Why are people angry? Well, it boils down to 3 reasons. Electricity bills. Goldman Sachs warned in early 2026 that consumer electricity prices are expected to jump 6% between 2026 and 2027, driven largely by data center demand. People are watching their energy bills go up, and they know why. Water. Cooling large data centers can consume millions of liters of water per year. In drought-prone regions, that's an existential issue that can take lives. Jobs versus noise. Data centers create very few permanent jobs relative to their size. A facility that occupies a 50-acre site might employ 30 to 50 people. Communities that were promised economic booms are getting electricity substations and a fence instead. In Virginia, the world's largest data center market, residents have been clashing with developers for years. Protests have spread to Oregon, Tennessee, Georgia, and beyond. If you're building a data center, you're not just dealing with construction permits. You're dealing with local governments, utility companies, environmental regulators, and residents who are increasingly organized and increasingly effective. All right, you've built it. You've survived the grid queue. You've made peace with the neighbors. Now you have to run it. Here's what a typical large data center costs to operate every year. Electricity, $41 million to $131 million, your single biggest cost by far. Hardware refresh. Servers and IT equipment need to be replaced every 5 to 6 years. Spread across the life cycle of a 100 megawatt facility, that's $417 million to $800 million amortized, or roughly $70 million to $130 million per year. Infrastructure maintenance. The building, power systems, cooling, and fire suppression. Another $10 million to $25 million per year. Staffing. 24/7 operations require engineers, security, and support staff, adding $5 million to $10 million annually. Total annual operating cost for a large facility, somewhere between $150 million and $400 million per year, before you've made a single dollar. There are 2 main business models for a data center. Model 1, co-location. Build the facility and rent out space, power, and cooling to other companies who bring their own servers. You charge by the kilowatt. Essentially, you're a landlord, and electricity is the rent. In 2026, a 5 megawatt co-location facility in a power-constrained market can generate somewhere between $5 million and $14 million per year in revenue at high utilization. Scale that to a 100 megawatt facility, and you earn anywhere between $100 million and $280 million. Model 2, hyperscale leasing. You build to spec for a single massive tenant, Amazon, Google, Microsoft, on a long-term lease. These deals are worth hundreds of millions per contract and represent the gold rush of the current moment. Hyperscalers sign leases worth over $100 billion in combined value in just 6 months between late 2025 and early 2026. The catch? You need to be able to build at scale in their preferred locations with power already secured. That means the people winning these contracts are already billion-dollar infrastructure companies. But here's the good news. You don't have to build the biggest facility in the world to win. Smaller, specialized facilities in underserved markets are getting premium pricing right now because demand is outstripping supply almost everywhere. Here's the number that should make you sit up. The four biggest hyperscalers, Alphabet, Microsoft, Meta, and Amazon, are projected to spend a combined $700 billion on AI infrastructure in 2026 alone. $700 billion. In 1 year. NVIDIA forecasts that global data center capital expenditure will reach $3 to $4 trillion annually by 2030. AI workloads currently represent about 25% of all data center capacity. By 2030, that's projected to reach 50%. This isn't a tech trend, this is the largest infrastructure build-out in human history. And unlike the dot-com bubble of 2000, the demand here is real and measurable. Every company in every industry is integrating AI. Every AI model needs to run somewhere. Every inference, every time you ask a chatbot a question, burns compute. There are currently around 3,000 data centers in the United States. Industry forecasts suggest that the number needs to grow dramatically just to keep up with AI inference demand by the late 2020s. The world is not building fast enough. The power grid is not expanding fast enough. The equipment supply chain is not moving fast enough. Which means if you can solve even one of those problems, power, location, or capital, you have a business. Let's be honest. If you're a solo entrepreneur with a few $1 million, you are not buying a hyperscale data center. That ship has sailed, and it's sailing at $700 billion a year. But here's what is still accessible. Smaller co-location facilities in secondary markets, mid-sized American cities, Southeast Asia, Africa, Eastern Europe, where demand is growing and supply is essentially zero. Edge data centers are closer to end users, serving the latency-sensitive applications that hyperscale facilities hundreds of miles away can't serve well. Specialized facilities, built specifically for AI training, for regulated industries like healthcare and finance, or for government sovereign cloud requirements. The data center industry is enormous, and enormous industries have room for more than 4 companies. The barriers are real. Capital requirements, power access, regulatory approval, and community relations are all genuinely hard problems. But the returns for the people who solve them? In an industry growing at 33% per year, with demand outpacing supply in almost every market, those returns are, to put it mildly, interesting. Just make sure you've sorted your electricity situation before you break ground. Because in 2026, power is everything. And without it, your data center is just a very expensive warehouse. If you made it this far, you now understand more about data center economics than most people who've never tried to build one. If you want us to keep breaking down the businesses nobody talks about, subscribe. We cover the businesses and assets most people will never own, but everyone should know how they work. And we will see you in the next episode of How to Buy.